Thank you all for joining me tonight. I appreciate you being here, and I hope this talk will guide you gently into a restful sleep. Tonight, we'll embark on a soothing journey to Mars, exploring the fascinating details of the Red Planet. We'll learn about its striking landscape, composed of the largest volcano in the solar system, Olympus Mons, and the Grand Canyon, Valles Marineris. We'll delve into the mysteries of its past, its potential for future human exploration, and the ongoing quest to discover whether life ever existed there. As we traverse the Martian surface in our minds, let the vastness and serenity of space calm your thoughts and ease you into a state of deep relaxation. So, lie back, close your eyes, and let the wonders of Mars lull you into peaceful slumber. 1. Mars, often referred to as the Red Planet, is a fascinating world with many unique features and intriguing facts. 2. Mars appears red due to iron oxide, or rust, on its surface. It is the fourth planet from the Sun, located about 140 million miles to 128 million kilometers away. It has a diameter of about 4,000 to 120 miles, 6,790 kilometers, roughly half the size of Earth. 3. A day on Mars, called a sol, is slightly longer than an Earth day at about 24.6 hours. A Martian year, however, lasts 687 Earth days. 4. Mars is much colder than Earth, with average surface temperatures around -80 degrees Fahrenheit, 60 degrees Celsius. Temperatures can vary widely, ranging from -195 degrees Fahrenheit -125 degrees Celsius during winter at the poles to 70 degrees Fahrenheit 20 degrees Celsius in summer near the equator. 5. Mars hosts the tallest volcano in the solar system, Olympus Mons, which stands about 13.6 miles 20 kilometers high. It also has a canyon system, Valles Marineris, that stretches over 2,500 miles for 1,000 kilometers and is up to 7 miles 11 kilometers deep in places. 6. The Martian atmosphere is thin, composed mostly of carbon dioxide 95.3%, with traces of nitrogen 2.7% and argon 1.6%. The thin atmosphere means there is very little air pressure, less than 1% of Earth's. 7. Mars has two small moons, Phobos and Deimos, which are thought to be captured asteroids. Phobos orbits Mars very closely and completes an orbit in just 7.7 hours, while Deimos takes about 30.3 hours to orbit the planet. 8. Evidence suggests that Mars once had liquid water on its surface. Features such as dried-up river beds, ancient lake beds, and minerals that form in the presence of water indicate that the planet may have supported water billions of years ago. 9. Mars has seasons similar to Earth due to its axial tilt of 25.2 degrees. However, its seasons are nearly twice as long because a Martian year is about 687 Earth days. 10. The planet experiences dust storms that can cover its entire surface. These storms can last for months and are the largest in the solar system, sometimes obscuring the planet's surface entirely. 11. Mars has been a target for many space missions. NASA's Curiosity rover, which landed in 2012, has been exploring Gale Crater to study the planet's climate and geology. The Perseverance rover, which landed in 2021, is searching for signs of past life and collecting samples for future return to Earth. 12. There are plans for future human exploration of Mars. NASA's Artemis program aims to return humans to the Moon as a stepping stone to Mars, with the goal of sending astronauts to the Red Planet in the 2030s. 13. Mars has a thin atmosphere, which means it cannot retain heat well and lacks significant protection from space radiation. This presents challenges for future human missions in terms of temperature regulation and radiation shielding. 14. The gravity on Mars is about 38% of Earth's gravity, which means a person who weighs 100 pounds on Earth would weigh only 38 pounds on Mars. This lower gravity affects muscle and bone density, which is a key consideration for long-term human missions. 15. Mars' magnetic field is weak and fragmented, unlike Earth's strong and cohesive magnetic field. This lack of a global magnetic field means that Mars is more exposed to solar wind and cosmic radiation. 16. Mars has polar ice caps made of water and dry ice frozen carbon dioxide. The northern ice cap, Planum boreum, and the southern ice cap, Planum australe, expand and contract with the changing seasons. 17. The surface of Mars is home to numerous impact craters, evidence of its turbulent history. The largest impact basin, Hellas Planitia, is about 1,400 miles, 2,300 kilometers in diameter, and over 5 miles, 8 kilometers deep. 18. Mars has a rich geological history with evidence of volcanic activity, tectonic forces, erosion, and sedimentary layering. These processes have created a diverse landscape of valleys, plains, and mountains. 19. The Martian soil contains perchlorates, which are chemicals that can be both toxic and useful. Perchlorates could be a challenge for human health, but also a resource for producing oxygen and rocket fuel. 20. Mars' thin atmosphere allows for more meteoroids to reach its surface, resulting in a greater number of meteorite impacts compared to Earth, where the atmosphere burns up many incoming meteoroids. 21. The Martian year is divided into 12 months, like on Earth, but each month is longer due to the planet's longer orbital period around the Sun. 22. Mars has a weaker greenhouse effect than Earth. While its atmosphere contains carbon dioxide, the thinness of the atmosphere means it retains much less heat. 23. The planet's average atmospheric pressure is about 610 pascals, less than 1% of Earth's average sea level pressure of 101,325 pascals. 24. Mars experiences significant temperature fluctuations between day and night. Surface temperatures can drop by as much as 100 degrees Fahrenheit, 55 degrees Celsius after sunset. 25. Robotic missions have detected traces of methane in Mars' atmosphere. The presence of methane is intriguing because it could indicate geological activity or even microbial life, though its origin is still uncertain. 26. Mars has been a popular subject in science fiction, inspiring countless stories, films, and theories about Martian life and human colonization. The idea of terraforming Mars or altering its environment to make it habitable for humans is a frequent topic of speculation. 27. Seasonal changes on Mars cause the polar ice caps to grow and recede, creating features such as polar dunes and frost patterns. 28. Mars is named after the Roman god of war, reflecting its reddish appearance, which is reminiscent of blood. 29. Mars' low atmospheric density means that sound travels differently than on Earth. Sounds would be quieter and lower in pitch, and communication devices would need to be adapted for this environment. 30. The exploration of Mars has provided valuable insights into the planet's potential for past habitability and its suitability for future human missions, enhancing our understanding of planetary science and our place in the universe. 31. Mars' atmosphere is composed primarily of carbon dioxide, but it also contains small amounts of nitrogen and argon, along with traces of oxygen and water vapor. 32. Dust devils are common on Mars and can be very large. These small, whirlwind-like storms can lift dust from the surface, creating dark streaks as they move across the landscape. 33. The average thickness of Mars' crust is about 30 to 50 kilometers, which is significantly thicker than Earth's crust. This thicker crust is one reason why Mars has larger volcanoes. 34. Mars' rotational axis is tilted at an angle of about 25 degrees, which is similar to Earth's tilt. This tilt causes the planet to experience seasons, although they are roughly twice as long as Earth's seasons due to its longer orbital period. 35. The first successful flyby of Mars was by NASA's Mariner 4 in 1965, which provided the first close-up photos of the Martian surface. 36. Mars has an equatorial diameter of approximately 4,000 to 117 miles, 6,794 kilometers, making it the second smallest planet in the solar system, only larger than Mercury, 37. In addition to the two main ice caps, Mars has mid-latitude glaciers. These glaciers are composed mostly of water ice, hidden beneath a layer of rocky debris, 38. The gravity on Mars is about 0.375 that of Earth's, which would affect how humans move and operate equipment on the planet, 39. In the Martian atmosphere, there is a phenomenon known as the blue sunset, caused by the scattering of sunlight by the fine dust particles in the atmosphere. The sky appears blue at sunset, contrasting with the red sky seen during the day, 40. Mars has been visited by several robotic missions, including orbiters, landers, and rovers. These missions have greatly expanded our understanding of the planet's geology, climate, and potential for past life. 41. The largest canyon on Mars, Valles Marineris, is more than 10 times longer, 5 times deeper, and 20 times wider than the Grand Canyon on Earth. 42. The concept of a Martian day or sol is used in mission planning for rovers and landers on Mars, as their operations need to be synchronized with the Martian day-night cycle. 43. The thin Martian atmosphere means that liquid water cannot exist on the surface for long, as it would quickly evaporate or freeze. 44. Mars has regions of high radiation levels due to its thin atmosphere and lack of a global magnetic field. This presents challenges for both robotic missions and potential human explorers. 45. The surface of Mars is covered in a fine dust that contains a significant amount of iron oxide. This dust can pose challenges for equipment and instruments on rovers and landers. 46. Despite its dry appearance today, Mars shows many signs of having had a significant amount of water in the past, such as ancient river channels and lake beds. 47. The temperature on Mars can change dramatically from day to night due to the thin atmosphere, which provides little insulation. 48. The presence of recurring slope linea RSL on Mars suggests that briny water may occasionally flow on the planet's surface. 49. The InSight mission, which landed on Mars in 2018, has been studying the planet's interior structure by detecting Marsquakes and other seismic activity. 50. Future missions to Mars include plans for sample return missions, which aim to bring back Martian soil and rock samples to Earth for detailed analysis. 51. Mars has a feature known as the Medusae-Fossae Formation, which is a large, unusual deposit of soft, easily eroded material. This formation may have been created by volcanic or wind activity. 52. The atmosphere on Mars is about 100 times thinner than Earth's, which makes it difficult for the planet to retain heat. As a result, temperatures can plummet drastically at night. 53. Mars has a series of large shield volcanoes similar to those found in Hawaii, with Olympus Mons being the largest. These volcanoes are believed to have been active millions of years ago. 54. The rover Opportunity, which operated from 2004 to 2018, holds the record for the longest distance driven on another planet, covering about 28 miles 45 kilometers on the Martian surface. 55. Mars has numerous surface features that suggest the presence of ancient water flow, including outflow channels, valley networks, and delta formations. 56. The Phoenix lander, which arrived on Mars in 2008, confirmed the presence of water ice in the Martian soil. 57. Mars has a very low atmospheric pressure, which is less than 1% of Earth's at sea level, making the existence of liquid water on the surface virtually impossible under current conditions. 58. The Mars Reconnaissance Orbiter has been mapping the planet's surface in high detail since 2006, providing valuable data on the planet's climate and geology. 59. Mars' thin atmosphere means that meteors are less likely to burn up before reaching the surface, resulting in a higher frequency of meteorite impacts compared to Earth, 60. The planet's dust storms can be so intense that they cover the entire planet and last for months, significantly reducing sunlight and affecting solar-powered equipment, 61. The Martian soil contains a variety of minerals, including silicates, sulfates, and chlorides, which have been studied by various landers and rovers to understand the planet's geologic history, 62. Mars is often visible to the naked eye from Earth and can be identified by its reddish appearance in the night sky, making it a prominent feature for amateur astronomers and sky watchers. 63. The Martian moons, Phobos and Deimos, are thought to be captured asteroids from the asteroid belt. Phobos orbits extremely close to Mars and is gradually spiraling inward, which means it will eventually either crash into Mars or break apart. 64. Mars has a lower density than Earth, which is why its gravitational pull is weaker despite being roughly half the size of Earth. 65. The Martian year is divided into 3 distinct seasons: spring, summer, and autumn due to its elliptical orbit around the Sun. This results in seasons that vary significantly in length and temperature. 66. The temperature on Mars can swing widely during the day, with daytime temperatures reaching up to 70 degrees Fahrenheit, 20 degrees Celsius, and nighttime temperatures dropping to as low as -195 degrees Fahrenheit, -125 degrees Celsius. The Curiosity rover discovered evidence of ancient organic molecules in Martian rocks, suggesting that the building blocks of life may have existed on Mars billions of years ago. 68. Mars has a thin layer of atmosphere that contains trace amounts of water vapor, which can form thin clouds and frost on the surface. 69. The surface gravity on Mars is about 38% of Earth's, which would make objects and people weigh less and potentially affect human muscle and bone density over time. 70. Mars' weak magnetic field means that it does not have the same level of protection from cosmic radiation as Earth does, posing a significant challenge for future human missions. 71. The Mars Pathfinder mission in 1997 included the first successful rover, Sojourner, which demonstrated the feasibility of rovers operating on the Martian surface. 72. Mars has been the subject of various Marsquakes, which are seismic activities detected by the InSight lander. These quakes provide clues about the planet's interior structure. 73. Mars' climate has varied significantly over its history, with periods of warmer, wetter conditions that might have been conducive to life. 74. Mars has numerous dust-filled valleys and plains that are believed to be remnants of ancient, vast lakes and river systems. 75. Mars has significant seasonal polar ice caps that grow and shrink as the planet tilts toward and away from the Sun during its orbit. 76. The thin atmosphere on Mars means that the sky appears butterscotch or reddish during the day due to the scattering of sunlight by fine dust particles. 77. The Mars Odyssey orbiter has been mapping the planet's surface since 2001, providing data on the planet's composition, surface temperature, and radiation environment. 78. Mars is one of the most studied planets, with numerous missions planned, including the ExoMars rover by the European Space Agency (ESA) and the Rosalind Franklin rover set to launch in the near future. 79. The thin Martian atmosphere and lower gravity allow for more extreme topographic features, such as taller mountains and deeper valleys compared to Earth. 80. The presence of hematite blueberries, discovered by the Opportunity rover, indicates that liquid water once existed on Mars and played a role in the planet's geological processes. 81. Mars has a phenomenon called transient luminous events, which are brief flashes of light caused by electrical activity in the atmosphere, similar to lightning on Earth. 82. The MAVEN Mars Atmosphere and Volatile Evolution mission studies the Martian upper atmosphere, helping scientists understand how the planet lost most of its original atmosphere over time. 83. Mars' rotation period and seasonal cycles are very similar to those of Earth, making it one of the most Earth-like planets in the solar system in terms of day length and seasonal changes. 84. The planet's lower gravity and thinner atmosphere mean that sound travels differently on Mars. Sounds would be fainter and lower pitched than on Earth. 85. The concept of terraforming Mars to make it more Earth-like involves several proposed methods, such as releasing greenhouse gases to warm the planet or creating artificial magnetic fields to protect against radiation. 86. Mars' distinctive surface features include a variety of impact craters, volcanic plains, and layered sedimentary rock formations, which provide evidence of the planet's complex geological history. 87. The Mars Global Surveyor mission, which operated from 1997 to 2006, produced detailed maps of the Martian surface and topography, greatly enhancing our understanding of the planet's geography. 88. Mars' thin atmosphere and distance from the Sun contribute to its harsh and frigid climate, making it a challenging environment for both robotic and potential human exploration. 89. The search for life on Mars focuses on finding signs of past microbial life in ancient, habitable environments such as the ancient lake beds explored by rovers like Perseverance. 90. Mars' axial tilt experiences more significant variations over millions of years compared to Earth, affecting the planet's climate and potentially its habitability over geological timescales. 91. Mars' thin atmosphere results in low air pressure, making it impossible for liquid water to exist on the surface for extended periods without evaporating or freezing. 92. The first spacecraft to successfully land on Mars was Viking 1, which touched down in 1976 and provided the first clear images of the Martian surface. 93. Mars' north and south hemispheres have very different terrains. The northern hemisphere is composed of flat, low-lying plains, while the southern hemisphere is heavily cratered and mountainous. 94. The Mars Express orbiter, launched by the European Space Agency, has been studying the planet since 2003, providing valuable data on Mars' atmosphere, surface, and subsurface. 95. Mars' polar regions contain layered deposits of ice and dust that provide a record of the planet's climate history over millions of years. 96. Mars has a unique feature known as the Tharsis region, which is a vast volcanic plateau that hosts some of the largest volcanoes in the solar system. 97. The atmosphere of Mars is rich in carbon dioxide, with only trace amounts of oxygen, nitrogen, and water vapor, making it unbreathable for humans. 98. The discovery of recurring slope linea (RSL) suggests that salty water may occasionally flow on Mars, indicating potential habitats for microbial life. 99. The Mars Atmosphere and Volatile Evolution MAVEN mission has been studying how the solar wind strips away the Martian atmosphere, contributing to the planet's loss of water. 100. Mars' surface is rich in iron, giving it its characteristic red color, but it also contains elements like silicon, oxygen, and aluminum. 101. The planet's surface shows evidence of ancient river deltas and lake beds, suggesting that liquid water was once present in large quantities. 102. Mars' distance from the Sun means it receives less solar energy, contributing to its cold temperatures and making it less hospitable for life as we know it. 103. The Mars 2020 mission, with its Perseverance rover, aims to search for signs of ancient life and collect samples for a future return to Earth. 104. Mars dust storms can produce static electricity, which could pose challenges for future exploration equipment and human missions. 105. The Jezero crater, where the Perseverance rover landed, is believed to have once contained a lake and river delta, making it a prime location for searching for signs of past life. 106. Mars has seasonal polar ice caps that are primarily composed of water ice and dry ice frozen carbon dioxide, which expand and contract with the seasons. 107. The planet experiences significant dust storms, which can sometimes cover the entire planet and last for weeks, affecting visibility and solar panel efficiency. 108. The Martian surface is covered with a layer of fine dust that contains toxic chemicals, such as perchlorates, which can pose risks to human health and equipment. 109. Mars has a variety of surface features, including ancient river valleys, impact basins, and volcanic plains, which provide clues about its geologic history. 110. The atmospheric pressure on Mars is so low that liquid water cannot exist on the surface for long without evaporating or freezing. 111. The planet's weak magnetic field and thin atmosphere expose the surface to higher levels of cosmic and solar radiation compared to Earth. 112. Mars has experienced significant volcanic activity in the past, with evidence of lava flows, volcanic plains, and giant shield volcanoes. 113. The polar ice caps contain layers of ice and dust that provide a record of the planet's climate changes over millions of years. 114. Mars' thin atmosphere results in a weak greenhouse effect, leading to colder surface temperatures compared to Earth. 115. The planet has a variety of wind-shaped features, such as dunes and ripples, indicating active wind erosion and sediment transport. 116. Mars has seasonal variations in methane levels, which could be linked to geological activity or even biological processes. 117. The planet's surface has many large canyons and valleys, such as Noctis labyrinthus, a maze-like system of deep troughs. 118. Mars has a rich history of exploration, with over 50 missions sent to study the planet, including orbiters, landers, and rovers. 119. The Martian day, or sol, is only about 40 minutes longer than an Earth day, making timekeeping on Mars relatively straightforward for human missions. 120. Mars has areas of high radiation levels due to its thin atmosphere and lack of a global magnetic field, posing challenges for long-term human habitation. 121. The planet's lower gravity affects everything from human physiology to how vehicles and equipment are designed for exploration and potential colonization. 122. The Hellas Basin on Mars is one of the largest impact craters in the solar system, stretching about 1,400 miles, 2,300 kilometers in diameter, and over 5 miles, 8 kilometers deep. 123. Mars has no liquid water on its surface today, but large amounts of frozen water are locked in its polar ice caps and possibly underground. 124. The Martian atmosphere contains about 0.13% oxygen compared to 21% in Earth's atmosphere, making it unsuitable for human breathing without life support systems. 125. Dust devils on Mars are much larger and more powerful than those on Earth, capable of reaching heights of several kilometers and moving at speeds of over 60 miles per hour, 100 kilometers per hour. 126. Mars has several ancient river valleys, such as Ares Vallis and Madime Vallis, indicating that liquid water once flowed across its surface. 127. The surface of Mars is heavily cratered, with some of the oldest and most preserved impact craters in the solar system, offering insights into the planet's early history. 128. Mars' surface gravity is about 0.375 of Earth's, which would significantly reduce the weight of objects and humans on the planet. 129. Seasonal changes on Mars can cause frost to form on the surface, especially in the polar regions, where temperatures can drop extremely low. 130. The Mars Science Laboratory mission, with its Curiosity rover, has been exploring Gale Crater since 2012, studying the planet's climate and geology to assess past habitability. 131. Mars' thin atmosphere means that meteoroids are more likely to reach the surface, leading to a higher rate of meteorite impacts compared to Earth. 132. The ExoMars program, a joint mission by the European Space Agency and Roscosmos, aims to search for signs of past and present life on Mars 133. Mars has many highland regions, such as the Tharsis and Arabia Terra regions, which are characterized by ancient, heavily cratered terrain 134. The Martian surface has numerous geological features called chaotic terrains, where large blocks of crust have been broken up and jumbled together, possibly due to past water activity 135. The planet experiences auroras similar to Earth's northern and southern lights caused by the interaction of solar wind with the atmosphere and magnetic field anomalies 136. The Martian ionosphere, a layer of charged particles high in the atmosphere, varies greatly with solar activity and has been studied to understand the planet's atmospheric dynamics 137. Mars has an intriguing feature known as the face on Mars, a mesa in the Cydonia region that resembles a human face when viewed from orbit, sparking speculation and interest in popular culture. 138. Mars has a diverse range of surface colors, including red, brown, gold, and greenish hues, resulting from different minerals and rock types 139. The Martian surface shows signs of tectonic activities, such as fault lines and valleys, suggesting that the planet's crust has been fractured and shifted over time 140. Mars has ancient lake beds like the one in Gale Crater, where sedimentary layers suggest that water persisted for long periods, potentially creating habitable environments 141. Mars has regions of exposed bedrock that are rich in clay minerals, indicating that water was present for an extended time and altering the rock's composition 142. The planet's thin atmosphere allows for the rapid cooling of the surface at night, causing significant temperature fluctuations between day and night 143. Mars' equatorial region contains features like the Medusae Fossae Formation, a large and enigmatic deposit that may be the result of volcanic or aeolian wind-driven processes 144. The Martian atmosphere contains trace amounts of noble gases such as argon and neon, which help scientists understand the planet's atmospheric evolution 145. Mars has regions with significant deposits of sulfates and other salts, indicating the past presence of evaporating bodies of water. 146. The planet's southern hemisphere is dominated by ancient, heavily cratered highlands, while the northern hemisphere consists of younger, lower-lying plains 147. Mars experiences seasons of dust storms, which occur when the planet is closest to the Sun and can result in global dust coverage 148. The Mars Pathfinder mission demonstrated the first use of an airbag landing system to safely deliver the Sojourner rover to the surface 149. Mars has frequent dust devils, which are small whirlwinds that can lift dust and sand, cleaning solar panels on rovers like Opportunity and Spirit 150. Mars' thin atmosphere and lack of liquid water on the surface mean that rusting occurs very slowly, preserving iron-rich rocks and meteorites for millions of years 151. The Mars Direct Plan, proposed by NASA engineers, outlines a relatively low-cost human mission to Mars, utilizing current technology and in-situ resource utilization 152. The Martian soil contains various oxidizing chemicals which pose challenges for detecting organic molecules and potential biosignatures 153. Future missions to Mars aim to establish a human presence with goals including building habitats, growing food, and producing fuel from local resources to support long-term exploration and potential colonization. 154. Mars has a feature called the Seven Sisters, which are 7 prominent ridges in the Candor Chasma region of the Valles Marineris Canyon system 155. The planet's thin atmosphere and distance from the Sun make solar power a viable energy source for rovers and potential future human missions 156. Mars' surface is dotted with large plains covered with volcanic basalt, indicating widespread volcanic activity in the planet's past 157. The Martian moon Phobos is slowly getting closer to Mars and will either crash into the planet or break apart and form a ring in about 50 million years, 158. Mars has several large impact basins, such as Argyre Planitia and Isidis Planitia, which provide clues about the planet's early history and the impacts it has endured, 159. The planet's atmosphere is too thin to support liquid water on the surface, but seasonal dark streaks known as recurring slope linea suggest the presence of briny liquid water just below the surface, 160. Mars' low temperatures and thin atmosphere cause carbon dioxide frost to form at night, especially near the poles, 161. The study of Martian meteorites, which have landed on Earth, provides direct samples of the planet's composition and history, 162. Mars' surface features many wine-sculpted rock formations, such as yardangs, which are streamlined ridges formed by wind erosion, 163. The Mars InSight lander, which arrived in 2018, has been studying the planet's interior by measuring seismic activity and heat flow, 164. Mars has a number of lava tubes, which are tunnel-like structures formed by flowing lava that could potentially be used as shelters for future human explorers, 165. The planet's axial tilt undergoes significant changes over long periods, which can lead to dramatic climate shifts and ice ages, 166. Mars has several features known as chaos terrains, where large blocks of the surface appear to have been broken and jumbled, possibly by the release of subsurface water or ice, 167. The Mars Reconnaissance Orbiter has detected evidence of hydrated minerals, suggesting the past presence of water altering the surface rocks, 168. The Viking landers in the 1970s conducted experiments searching for microbial life, and while results were inconclusive, they continue to influence the design of modern missions, 169. The Martian sky often appears pink or reddish during the day due to the scattering of sunlight by dust particles in the atmosphere. 170. Mars has large canyon systems, such as Valles Marineris, which stretches over 2,500 miles for 1,000 kilometers and is up to 7 miles 11 kilometers deep in some areas. 171. The planet's surface is dotted with ancient river deltas, like the one found in the Eberswalde crater, indicating that flowing water once shaped the landscape. 172. Mars experiences frequent and intense dust storms that can last for days or even weeks, significantly reducing sunlight and temperatures. 173. The northern lowlands of Mars may have once contained an ocean, supported by evidence of ancient shorelines and sediment deposits. 174. The Martian subsurface is a potential habitat for microbial life, with scientists investigating the possibility of liquid water reservoirs beneath the surface. 175. Mars' atmosphere contains about 0.03% water vapor, which is a tiny fraction of Earth's, but it can condense to form thin clouds and frost. 176. The discovery of hematite blueberries by the Opportunity rover suggests that Mars had liquid water that may have created favorable conditions for life. 177. Mars Olympus Mons volcano is so large that its base would cover the entire state of New Mexico in the United States. 178. The planet's southern hemisphere has many high-altitude craters, indicating a thick and ancient crust that has been relatively undisturbed by geological activity. 179. Mars' magnetic field is weak and localized in certain areas, unlike Earth's strong and global magnetic field, providing less protection from solar radiation. 180. Mars has been a popular subject in science fiction, inspiring numerous books, movies, and TV shows about human exploration and colonization of the Red Planet. 181. The Martian year is 687 Earth days, almost twice as long as a year on Earth, resulting in longer seasons. 182. The Mars Curiosity rover found ancient stream beds with rounded pebbles, indicating the presence of flowing water in the planet's past. 183. Mars has a relatively small core compared to Earth, and it is composed of iron, nickel, and sulfur, with ongoing research about its exact state and composition. 184. The planet's gravity is only about 38% of Earth's, which would affect human muscles and bones during long-term stays. 185. Mars has been mapped in high resolution by various orbiters, creating detailed topographic maps that help scientists plan future missions and understand its geology. 186. Mars has two small moons, Phobos and Deimos, which are irregularly shaped and likely captured asteroids from the asteroid belt. 187. The Viking landers conducted the first experiments on Mars' surface to search for signs of microbial life in the 1970s, with mixed results that are still debated today. 188. Mars' largest canyon system, Valles Marineris, is longer and deeper than the Grand Canyon on Earth, with its deepest point reaching about 7 miles 11 kilometers below the Martian surface. 189. The Mars Odyssey orbiter, launched in 2001, has been mapping the distribution of water ice and other minerals on Mars using its infrared spectrometer. 190. Mars has a day-night cycle similar to Earth's, with a Martian day, or sol, lasting about 24 hours and 37 minutes. 191. The planet's atmosphere is constantly losing gases like hydrogen and oxygen into space due to the solar wind, contributing to its thin and tenuous nature. 192. The Gale crater, where the Curiosity rover landed, contains a central mountain called Mount Sharp, which is about 3.4 miles (5.5 kilometers) high and contains layers of sedimentary rock. 193. Mars' northern hemisphere is mostly flat and contains large plains, while the southern hemisphere is more rugged and heavily cratered. 194. The Mars Global Surveyor mission discovered evidence of ancient river valleys and lake beds, providing strong evidence that liquid water once flowed on the Martian surface. 195. Mars has a low average surface temperature of about -80 degrees Fahrenheit, -60 degrees Celsius, with colder temperatures at the poles and warmer temperatures near the equator during the day. 196. The planet's thin atmosphere allows for dust storms to reach global scales, covering large areas and affecting the planet's climate and visibility. 197. Mars has several volcanic regions, including Tharsis Tholis and Elysium, which are smaller volcanoes compared to Olympus Mons, but still significant in size. 198. The Mars Science Laboratory mission, with its Curiosity rover, has been exploring the planet's surface and investigating its geological history and potential habitability since 2012. 199. Mars has polar ice caps made up of water ice and frozen carbon dioxide dry ice, which expand and contract with the seasons. 200. The planet's thin atmosphere and lack of a global magnetic field make it more susceptible to solar and cosmic radiation, which could be harmful to future human explorers. 201. Mars has a distinctive reddish color due to iron oxide rust on its surface, which gives it the nickname the Red Planet. 202. The atmosphere of Mars is about 96% carbon dioxide, with very low levels of oxygen, about 0.1% compared to Earth's atmosphere. 203. Mars' atmosphere is so thin that the average surface pressure is less than 1% of Earth's atmospheric pressure at sea level. 204. The Martian moons, Phobos and Deimos, are irregularly shaped and have surface features that suggest they are captured asteroids. 205. Mars has large sand dunes, some of which are hundreds of feet high and extend for miles across the planet's surface. 206. The Gale crater, where the Curiosity rover landed, was chosen because it contains a central mountain that scientists believe formed from sedimentary layers over millions of years. 207. Mars has a range of surface temperatures, with highs around 70 degrees Fahrenheit, 20 degrees Celsius at the equator during the day, and lows of -195 degrees Fahrenheit, -125 degrees Celsius at the poles during winter nights. 208. The planet's surface gravity is about 38% of Earth's, meaning a person who weighs 100 pounds on Earth would weigh about 38 pounds on Mars, 109. Mars has evidence of ancient volcanic activity, with lava flows, volcanic cones, and extensive lava plains visible on its surface, 210. The Mars Pathfinder mission was the first successful landing on Mars since the Viking missions, deploying the Sojourner rover to explore the Martian surface in 1997, 211. Mars' thin atmosphere causes the sky to appear butterscotch or pinkish during the day and to exhibit a blue tinge near the horizon at sunset, 212. Mars has a complex system of impact craters, ranging from small, simple craters to large, complex ones like Hellas Planitia, which is one of the largest impact basins in the solar system, 213. The planet's axis tilt is similar to Earth's, which means it experiences seasons similar to Earth's, though they are about twice as long due to its longer orbital period, 214. Mars has been visited by a series of successful robotic missions, including orbiters, landers, and rovers, from various space agencies around the world, 215. The Mars Reconnaissance Orbiter (MRO), launched in 2005, has been studying the planet's surface, climate, and atmosphere in high resolution, providing valuable data for future missions and exploration. 216. Mars has a diverse range of surface features, including volcanoes, impact craters, valleys, and plains, which provide evidence of its geologic history spanning billions of years. 217. The planet's largest volcano, Olympus Mons, is about 13.6 miles 22 kilometers high, making it the tallest volcano in the solar system, 3 times taller than Mount Everest, 218. Mars has the largest known impact crater in the solar system, Hellas Planitia, which is about 1,400 miles 2,300 kilometers in diameter and nearly 5 miles 8 kilometers deep, 219. The Mars Pathfinder mission deployed the first rover, Sojourner, to explore the Martian surface and conduct experiments on soil composition and weather, 220. Mars has a diverse mineralogy, with rocks containing basalt, olivine, and clay minerals, providing insights into the planet's past environmental conditions, 221. The planets to moons, Phobos and Deimos, are irregularly shaped and thought to be captured asteroids due to their small size and unusual orbits, 222. Mars experiences seasonal polar caps made of water ice and dry ice frozen carbon dioxide, which grow and shrink with the changing seasons, 223. The Mars Express orbiter, launched by the European Space Agency in 2003, has been studying the planet's atmosphere, surface, and subsurface with its suite of instruments, 224. Mars has a diverse range of surface textures, from smooth plains to rugged highlands, indicating different geological processes shaping the landscape over time, 225. The planet's thin atmosphere contains dust storms that can cover the entire planet and last for weeks or even months, affecting visibility and surface temperatures, 226. Mars has regions with exposed bedrock that contain evidence of past water activity, including river channels, lake beds, and mineral deposits formed in aqueous environments, 227. The Mars Atmosphere and Volatile Evolution MAVEN mission studies how the planet's atmosphere interacts with the solar wind and loses gases into space over time, 228. Mars' climate is influenced by its orbital eccentricity and axial tilt, leading to significant variations in temperature and atmospheric pressure over the course of its year, 229. The planet's surface gravity allows for the formation of large-scale geological features such as towering volcanoes and deep canyons shaped by volcanic and erosional processes, 230. Mars has a variety of wind-carved features, including Yardang's elongated wind-sculpted ridges and dust devils, which contribute to ongoing surface erosion and landscape evolution. 231. Mars has a diverse range of geological settings, including extensive lava flows, massive shield volcanoes, and chaotic terrain, suggesting a dynamic and varied geological history. 232. The planet's surface is covered in regolith, a layer of loose, fragmented material created by impacts, volcanic activity, and wind erosion over billions of years. 233. Mars has an average surface temperature of about -80 degrees Fahrenheit, -60 degrees Celsius, but temperatures can vary widely depending on location, elevation, and time of day. 234. The Mars Exploration Rover Opportunity set a record for longevity, operating for over 14 years on Mars until it ceased communication in 2018 due to a dust storm. 235. Mars has a unique topography with features like the Tharsis Volcanic Plateau, home to Olympus Mons, and the Valles Marineris Canyon system, which is over 4,000 kilometers long. 236. The planet's atmosphere is composed primarily of carbon dioxide, with trace amounts of nitrogen, argon, oxygen, and other gases. 237. Mars has evidence of past glacial activity, including features like moraines, ridges of debris, and striation scratches left by moving ice. 238. The Mars Science Laboratory mission, with the Curiosity rover, discovered organic molecules and ancient rocks, suggesting that Mars may have once had conditions suitable for life. 239. Mars has a unique magnetic history, with evidence of magnetic fields recorded in ancient rocks that indicate past variations in the planet's magnetic field strength. 240. The planet's thin atmosphere allows for easier access to space compared to Earth, making it a target for future missions to explore and potentially colonize. 241. Mars has large dust storms that can obscure the entire planet for months, affecting solar-powered spacecraft and potentially human missions. 242. The planet's moons, Phobos and Deimos, have very low surface gravity, which would make walking on them challenging and potentially hazardous for astronauts. 243. Mars has regions with layered sedimentary rocks such as the Murray Formation explored by Curiosity, providing insights into past environmental conditions and the possibility of habitable environments. 244. The Mars InSight mission, launched in 2018, is studying the planet's deep interior using seismology to understand its structure and geological activity. 245. Mars has polar ice caps that contain layers of water ice and dust, providing a record of the planet's climate history and seasonal changes over millions of years. 246. The planet's surface features impact craters of various sizes and ages, offering clues about the frequency of impacts and the evolution of Mars' surface over time. 247. Mars has a unique global dust cycle where dust is lifted into the atmosphere by winds, creating regional and global dust storms that affect the planet's climate and surface conditions. 248. Mars has deep, narrow channels called fluvial valleys, believed to have been carved by ancient rivers and runoff from melting ice during periods of warmer climate in the planet's past. 249. The planet's largest impact crater, Hellas Planitia, is not only one of the largest, but also one of the deepest, with a central depression that reaches depths of up to 8 kilometers 5 miles. 250. Mars has a thin layer of oxidized iron dust covering its surface, giving it a reddish appearance due to the rusting of iron minerals in the presence of oxygen and water in the past. 251. The planet's axial tilt undergoes significant variations, leading to periodic changes in its climate and possibly contributing to the cycles of ice ages observed in Martian geological records. 252. Mars has transient streaks called recurring slope linea (RSL), which appear seasonally on steep slopes and are believed to result from the flow of briny water under certain conditions, indicating potential subsurface water activity. 253. The planet's moons, Phobos and Deimos, are irregularly shaped and are thought to be captured asteroids due to their small size, low density, and unusual orbits around Mars. 254. Mars has distinctive dark dune fields, such as those in the Arabia Terra region, which are shaped by wind erosion and movement of fine particles across the surface to 155. The Mars Climate Orbiter mission, launched in 1998, famously failed due to a navigation error caused by the use of different units of measurement between NASA and contractor teams, resulting in the loss of the spacecraft to 156. Mars has several prominent volcanic regions, including the Tharsis Montes and Elysium Mines, which are shield volcanoes formed by the eruption of low-viscosity lava over long periods, to 157. The planet's southern hemisphere has a more rugged and cratered terrain compared to the northern hemisphere, which is generally smoother and lower in elevation, 258. Mars has ancient impact basins, such as Isidis Planitia and Utopia Planitia, which contain evidence of past water flows and potential sites for future exploration and investigation of Martian history, 259. The Mars 2020 mission, with the Perseverance rover, aims to collect samples of Martian rock and soil for potential return to Earth in the future, enabling detailed analysis of Martian geology and potential biosignatures, to 160. Mars' thin atmosphere is constantly replenished by dust storms and volcanic eruptions, which inject particles and gases into the atmosphere and influence its dynamics and composition, 261. The planet's atmosphere undergoes seasonal variations in temperature and pressure, with colder temperatures and increased atmospheric density during winter in each hemisphere. 262. Mars has significant variations in surface elevation, with the Tharsis volcanic plateau containing some of the highest elevations on the planet, reaching up to 10 kilometers (6.2 miles) above its mean radius, 263. The planet's atmosphere contains methane, which varies seasonally and could be a potential indicator of biological or geological activity, although its exact source remains uncertain, 264. Mars has distinctive sedimentary rock formations, such as the Murray Formation explored by the Curiosity rover, which suggest past environments with flowing water and potential habitability, 265. The Mars Atmosphere and Volatile Evolution MAVEN mission has observed the escape of hydrogen and oxygen atoms from the upper atmosphere into space, contributing to the planet's atmospheric loss over time, 266. Mars' largest impact crater, the Argyre Basin, is about 1,800 kilometers (1,100 miles) in diameter and contains evidence of ancient lakes and river valleys carved into its rim and floor, 267. The planet's surface is home to large fields of volcanic rock and basaltic plains, such as those in the Syrtis Major region, indicating extensive volcanic activity in Mars' past, 268. Mars has a unique crustal dichotomy, with the southern hemisphere predominantly consisting of ancient cratered highlands and the northern hemisphere containing younger, smoother plains, 269. The Mars Odyssey orbiter detected vast amounts of hydrogen just beneath the surface, likely stored in the form of water ice and providing potential resources for future human exploration and habitation, 270. Mars' magnetic field is much weaker than Earth's and is localized in certain regions, such as crustal magnetization detected by orbiters and landers, indicating past episodes of dynamo activity, 271. The planet's surface is littered with small, iron-rich meteorites called siderites, which erode over time and contribute to the reddish color of the Martian regolith, 272. Mars has deep, ancient impact basins like the Utopia Planitia, where the Viking to lander touched down in 1976, conducting experiments on the surface and providing valuable data on Martian soil and atmosphere. The planet's surface is marked by seasonal frost, composed of carbon dioxide ice near the poles and water ice in lower latitudes, which sublimate and condense with changing seasons, to 174. Mars has a unique geologic feature known as yardangs, which are elongated, streamlined ridges formed by wind erosion of sedimentary rock layers, often found in wind-swept regions like Arabia Terra, to 175. The Mars Global Surveyor mission identified and mapped thousands of impact craters across the planet's surface, providing insights into the frequency and distribution of impact events over Martian history. 276. Mars' atmosphere has dust storms that can cover the entire planet, impacting surface operations of rovers and orbiting spacecraft and affecting global weather patterns over extended periods. 277. Mars has regions with extensive networks of small channels known as dendritic valleys, which resemble terrestrial river networks and suggest past erosion by flowing water. 278. The planet's atmosphere experiences daily temperature fluctuations, with daytime temperatures near the equator reaching highs of about 70 degrees Fahrenheit, 20 degrees Celsius, and nighttime temperatures dropping to lows of about -100 degrees Fahrenheit, -73 degrees Celsius. 279. Mars has evidence of widespread volcanic activity, with lava flows and volcanic plains covering large areas of the planet's surface, indicating a geologically active past. 280. The Mars Exploration Rover Spirit discovered silica-rich deposits known as home plate in the Gusev crater, suggesting past interactions between water and volcanic materials. 281. Mars' largest moon, Phobos, is slowly spiraling inward towards the planet due to tidal interactions, and it is predicted to either crash into Mars or break up and form a ring in the distant future. 282. The planet's thin atmosphere allows for significant temperature swings between day and night, with daytime temperatures on the equator sometimes rising above freezing and nighttime temperatures plunging far below. 283. Mars has features known as chaotic terrains, where blocks of terrain have collapsed and been jumbled together, possibly due to the melting of subsurface ice or volcanic activity. 284. The Mars Science Laboratory mission's Curiosity rover discovered ancient river deposits in Gale Crater, indicating that liquid water once flowed on the Martian surface. 285. Mars has polar ice caps made primarily of water ice, which expand and contract with the seasons, revealing layers that provide clues about the planet's climate history. 286. The planet's atmosphere experiences periodic global dust storms, which can obscure surface features, reduce sunlight reaching the surface, and affect spacecraft operations. 287. Mars has a variety of impact crater morphologies, including simple craters, complex craters with central peaks, and large multi-ring basins formed by catastrophic impacts in the planet's past. 288. The Mars InSight mission has detected Marsquakes or seismic activity, revealing insights into the planet's interior structure and tectonic activity. 289. Mars' surface is composed of a variety of rocks and minerals, including basalt, hematite, and sulfates, providing clues about the planet's geological evolution and past environmental conditions. 290. The planet's atmosphere is composed primarily of carbon dioxide, with a surface pressure averaging about 6 millibars, which is less than 1% of Earth's atmospheric pressure. 291. Mars has low-lying plains in the northern hemisphere, such as Acidalia planitia and Amazonas planitia, which contain evidence of ancient river valleys and fluvial erosion. 292. The Mars Odyssey orbiter detected significant amounts of hydrogen just beneath the surface, suggesting the presence of subsurface water ice deposits that could potentially support future human missions. 293. Mars' atmosphere is constantly losing gases like hydrogen and oxygen to space due to its weak magnetic field and the solar wind, which impacts its long-term atmospheric evolution. 294. The planet's surface features many impact craters with ejecta blankets and ray systems that provide information about the impact events and the geological history of Mars. 295. Mars has extensive fields of sand dunes, such as those in the northern polar region and near the equator, shaped by wind processes and composed of basaltic sand. 296. The Mars Reconnaissance Orbiter (MRO) has identified hydrated minerals on the planet's surface, indicating past interactions with liquid water and potential habitable environments. 297. Mars to moons Phobos and Deimos are small and irregularly shaped, with low densities and orbital characteristics that suggest they are captured asteroids. 298. The planet's surface contains features known as pedestal craters, where the ejecta material around a crater is more resistant to erosion, leaving the crater elevated above its surroundings. 299. Mars has seasonal polar caps composed of water ice and carbon dioxide ice, dry ice, which expand and contract with the changing seasons, influencing atmospheric dynamics. 300. The Mars Pathfinder mission included the first successful deployment of a rover Sojourner on the Martian surface in 1997, marking a milestone in planetary exploration.